Good morning, everyone. So, in the last lecture, we have seen the principle of the least action. State and prove. We have seen the statement as well as we have proved the principle of the least action. Right. So now we are going to see the last part of our third unit. That is a Jacobi's form of the principle of the least action. Okay. So after completion of the third unit, we are remaining with only one unit. That is the last unit. Okay. So do your study regularly so that you can cover the syllabus. Okay. करतायत ना सगळेजण अभ्यास? Hello, am I audible to everyone? Hello, आवाज येते का माझं?
Yes, ma'am.
Okay, let us go for the last part of this third unit. Jacobi's form of the principle of the least action. Okay, in the last lecture we have seen the principle of the least action. Now, what do you mean by principle of a least action? That is, okay, this is what the principle of the least action. Okay, now we want to see Jacobi's form. Okay, in case of a conservative scleronomic system itself. Okay, whatever we have seen yesterday, the same we will consider the case. Conservative scleronomic system. Okay, we have conservative scleronomic system. Right, what is kinetic energy in the case of conservative scleronomic system? Yes, in the last lecture also I have told you, you go through the unit 1 so that you can understand what is there. Okay, for the conservative scleronomic system, we know that the kinetic energy is given by, okay, for conservative scleronomic system, kinetic energy is given by P is equal to summation over Jk Ajk Qj dot Qk dot. Okay, that is kinetic energy is homogeneous quadratic function of a generalized velocity. We have proved this statement if you remember. Kinetic energy is homogeneous quadratic function of generalized velocity. Kinetic energy is homogeneous quadratic function of the generalized velocity. Okay, now this kinetic energy T, whatever we have written, summation over Ajk, this Ajk is a constant. Qj dot I can write dqj by dt, that is derivative of qj with respect to T is a qj dot. qk dot को कैसे लिख सकते हो? qk dot is nothing but derivative of qk with respect to T. Okay. Now this whole thing, Jacobi has done one substitution like derivative of some tau square divided by dt square. इसको उसने कुछ एक अलग फॉर्मेट में लिखा है, दो सिग्मा स्क्वायर बाय डी टी स्क्वायर, और उसने क्या सब्सटीट्यूशन लिखा है यहाँ पे, वेयर ये dou sigma instead of dou d sigma square is nothing but summation over a jk qj एंड क्यू के, और ये डी टी दोनों टर्म को आ जाएगा क्यू जे। मतलब कि क्या किया है उसने, ये वाला टर्म को उसने एक सब्सटीट्यूशन दिया है, राइट। व्हाट इज दिस टर्म, ही हैज नेम दिस एज डी सिग्मा स्क्वायर, और ये वाला डी टी स्क्वायर एज इट इज कैरी हो गया, ओके। So simply he has done some substitution and he has given his name that Jacobi's form of the principle of the least action. समजते सगळ्यांना? हॅलो,
Yes, ma'am.
रिप्लाय करत जावा, नाहीतर मला असं वाटतं की मी लेफ्ट मध्ये झाले का तुम्ही समजत नाही, तुम्हाला काय समजत नाही एक्झॅक्टली काय झाले, ओके. So from this equation I can write dt is equal to d sigma divided by under root t, okay. So this is, as it is a square, I can take a square root. Now what is the principle of a least action? The principle of the least action is given by delta integration t naught to t1 to t dt is equal to 0. So value of this dt you can write down from this, okay. ये वाला dt आपको सब्स्टिट्यूट करना है, जो जैकोबियंस ने सब्स्टिट्यूशन किया था, ओके। सिंपली उसने एक सब्स्टिट्यूशन यूज किया और उसने उसका नाम दे दिया द प्रिंसिपल ऑफ द लीस्ट एक्शन, ओके। जैकोबियंस फॉर्म ऑफ द प्रिंसिपल ऑफ द लीस्ट एक्शन. The dt is nothing but d sigma by under root t is equal to 0. Okay. Now this is t under root t. So this t I can write down as root t into root t. बरोबर? Yes or no? हॅलो, आहेत का सगळे? नसेल इंटरेस्टेड तर सांगा. आम्ही आम्ही पण ते ऑलरेडी लेक्चर जे अपलोड आहेत ना यूट्यूबवर तेच टाकतो रोज, ओके. क्योंकि ऑनलाइन हे रिकॉर्डेड लेक्चर साला रिकॉर्डेड लेक्चर के जैसे ही हुआ ना ये, कोई रिप्लाई देता नहीं है, कुछ नहीं है. सो व्हाई देयर इज necessary to take a live lecture, no? Okay, so this we have got t is written as under root t, which will get cancelled and we remains with this one. But we know that what we know, h is equal to t plus v in case of conservative scleronomic system. In the last lecture also I have told you, I remind you that h is equal to t plus v in the conservative scleronomic system. Okay, this was a question asked in the set exam. Physical significance. आठवतात का physical significance सांगितले होते? तिथे त्या लिहिले होते मी, ओके. दिस क्वेश्चन वॉज आस्क्ड इन द सेट एग्जाम 2015. Okay, h is equal to t plus v. So I can write down the value of t from this is nothing but h minus v. So again this equation can be written as integration t naught to t1 under root h minus v d my equal to 0. Okay, this is called the Jacobi's form of the principle of the least action. ओके, क्या किया है उसने यहाँ पे, सिर्फ ओनली एक चेंज क्या किया है, ये वाला पूरे टर्म को जो उसने ना साइन एक दे दिया है, एक नोटेशन यूज किया है. दैट नोटेशन इज नथिंग बट डी सिग्मा स्क्वायर, और इसके बेसिस पे उसने जस्ट टी का वैल्यू सब्स्टिट्यूट किया है, ओके. डी टी, ये डी टी का वैल्यू हमने यूज किया है, ओके. So actually today now we are having a lecture at 12, so I cannot start the next unit. अगर मैं next unit start करती हूँ तो थोड़ा सा uncomfortable हो जाएगा. Start करने के बाद immediately I have to close it. So what I will do, just I will introduce with what is a topic name. Next unit, unit 4, the last unit of our syllabus. Uh, Kinematics of a rigid body. Kinetics of the rigid body. In that, first we are going to study what is a rigid body. Okay. Yes. If you are having any doubt related to first unit, second unit, and third unit, you can ask. In the next lecture onwards, we'll start with the unit 4 rigid body. Then, actually, unit 4 is somewhat typically समेशन का जो यूज़ है ना वो बहुत ज़्यादा है यहाँ पे. अगर आपको समेशन अच्छे से इवेलुएट करना आता है तो आपको यूनिट 4 इजी लगेगा. अदरवाइज यू कैन नॉट इवेलुएट दिस. ओके. समय बहुत ज़्यादा यूज़ है समेशन का. थोड़ा कंफ्यूजिंग भी है तो आपको थोड़ा सा फैमिलियर होना पड़ेगा. समेशन कैसे इवेलुएट करते हैं, हाउ टू रन द समेशन, इफ समेशन इज ओवर द टू टर्म, समेशन ओवर जे, समेशन ओवर के, सो हाउ टू इवेलुएट that is a broader thing in the unit 4. Yes, starting from the first unit to third unit up, whatever the problem you have, you can discuss. Yes, no one having any problem first to last unit. First unit में हमने क्या देखा? Yes, anyone can repeat. Just क्या देखा हमने वो आप बता सकते हो. I think you have given a test on the first unit, no?
Yes, ma'am.
काय बघितलं फर्स्ट युनिट, सेकंड युनिट, थर्ड युनिट मध्ये? आतापर्यंत मीच बडबड करते ना. Yes, now you have to speak what we have seen in the first unit, second unit, and third unit.
Generalize the coordinates.
Yes? Yes, Vishal.
Generalize the coordinates.
Generalized coordinate. Next,
D'Alembert's principle.
DLMS principle. Yes.
Constraints, classification of constraints,
Yes, constraint, then the types of constraint, classification.
degrees of freedom, generalized coordinate,
Yes. Next,
Cyclic coordinates.
Lagrange's formulation
Lagrange's formulation is
for
a
conservative system, non-conservative system, and partially conservative and
good.
non-conservative.
Correct. For conservative, non-conservative, we get the same Lagrange's equation. For the non-conservative, we get some extra term is added. Correct. Next,
Lagrange's equation for simple pendulum, spherical pendulum,
correct. For simple pendulum, spherical pendulum.
cyclic coordinates,
Correct. And after that, we have seen kinetic energy for the is a homogeneous function of generalized velocity. ये सब थोड़े बहुत theorems देखे, right? What about the second unit? क्या देखा हमने second unit में? I think basic lemma of calculus of variation, and after that we have
yes,
seen Euler-Lagrange's
Euler-Lagrange's equation,
Euler-Lagrange's इक्वेशनचे 6 फॉर्म बघितले, त्यांचे प्रत्येकाचे एक एक्झाम्पल सॉल्व्ह केलं होतं, राईट?
alter delta annotation,
डेल्टा नोटेशन वी हैव सीन, राइट? थर्ड यूनिट में क्या देखा हमने? हैमिल्टन्स फॉर्मुलेशन एंड ड्यूडियन प्रोसीजर. ओके. हैमिल्टन्स क्या है, मॉडिफाइड हैमिल्टन्स क्या है, देन वेदर एल की जगह पे हम न्यू एल डैश जो कंस्ट्रक्ट किया था, राइट? न्यू एल डैश टू सेटिस्फाई हैमिल्टन्स प्रिंसिपल as well as new L dash to satisfy the Lagrange's equation of motion, right? Then we have seen Ruthian. Ruthian will work as a Hamilton for cyclic coordinate, and it work as a Lagrangian for the non-cyclic coordinate. We have solved an example also. Okay. So this is what we have seen in the 3 units. Okay. So if you are having any doubt related to first, second, third unit, you can ask. In the next lecture onwards, we will start with the Next point, next unit, that is a kinematics of the rigid body. Okay, now at 10:45 I have to leave the lecture because you have to join the guest lecture which was remaining. सर का कोई टाइमिंग फिक्स नहीं हो रहा था इसलिए अभी उनका शेड्यूल किया है. ओके, यू हैव टू अटेंड द लेक्चर. करतायत ना सगळे गेस्ट लेक्चर अटेंड करतायत ना?
Yes,
Oh,
ma'am.
yes, ma'am.
Okay, can you tell me what are the topics you have studied in the guest lecture? काय फक्त टॉपिक विचारते मी. ॲटलिस्ट स्टार्टिंगमध्ये पण तुम्ही असेल तर मीटिंगमध्ये तुम्हाला टॉपिक आठवत असेल. कुठलाही एक टॉपिक. सगळ्यांनी एक एक टॉपिक सांगा. किंवा कुठला पॉइंट तुम्हाला रिमेंबर असेल कुठल्याही लेक्चरमध्ये, गेस्ट लेक्चर.
Function and algebraic structure.
That is from Anant Hariharan sir.
Yes.
Right now?
Yes, ma'am.
Okay. Yes, anyone else remembering any topic?
Continuity and uniform continuity.
Okay, that is Sachin Ballal sir has teaches continuity and uniform. Next,
Application of graph theory.
application of the graph theory. Okay. Next,
Fractional
Women
calculus.
mathematicians.
Jain madam has explained you women mathematicians. Next, and complexity of a complex number. That was explained by Sadik Sheikh sir. Okay. And I think DD Pawar sir has explained you about the some research area. Fractional का सर ने आपको study करवाया था. Integral transform. Okay. Next, I think one more lecture was remaining, no? I think
Integral transform.
integral transform was conducted by DD Pawar sir. One more topic is remaining, no? What was that? Attachment. I think Sanket Tikare sir, introduction of time scale analysis. संकेत टीकारे सर टाइम थोड़ा रिसर्च एरिया का ही पॉइंट था. इंट्रोडक्शन टू टाइम स्केल कैलकुलस. Okay, these type of lectures from different eminent personalities from different universities. Okay, see, Sadiq Sheikh sir was from Aurangabad University. औरंगाबाद से ही थे वो सर. मौलाना आज़ाद कॉलेज बामा यूनिवर्सिटी के अंदर होता है. Next, DD Pawar sir from SRTM, Jain madam from SRTM. Then uh, I think next is Sanket sir was from Mumbai University. I think Anant Hariharan from IIT Bombay. He was from IIT Bombay. Okay, so these type of persons were there for the guest lecture. Now today also you have one more guest lecture. Okay. So if you're not having your doubt, you can leave the meeting and join the guest lecture at 10:45. Okay.